to go over Tuesday's lesson, which should be today. You should be watching this on Tuesday. Lesson 37, chemical compounds and parallelograms. First, we're going to do chemical compounds. This is more like a chemistry lesson than it is a math lesson, but there is math involved, so that's why it's a math lesson. Up here, you've probably heard of this before, H2O, which stands for water. That's the chemical name for water. This is a molecule, H2O, and it's broken into atoms. There's 2 hydrogen atoms and 1 oxygen atom in a water molecule. This is zinc nitrate, and it's 3 zinc atoms and 2 nitrate atoms, which makes zinc nitrate. So it's 3 zinc atoms, 2 nitrogen atoms. Every kind of atom, so this is made up of zinc and nitrogen. Each of those atoms has a specific molecular atomic weight. So that's what this is. So let's look at how you're going to use an example to do this. We have, here's our water molecule, H2O. They're going to give you in the problems what each atom weighs. Oxygen weighs 16 grams. Hydrogen weighs 1 gram. And they're going to give you a molecular weight. My husband's spelling me, and he looks really funny, that's why I'm laughing. If you have 3,600 grams of water, that's your molecular weight. They want us to find out what is the weight of oxygen. So we have the weight of the whole molecule. We need to find out what the weight of just one oxygen would be if it was 3,600, how much the oxygen would weigh. So we have hydrogen, there's 2 hydrogen atoms. So we have to take the weight of the hydrogen atom, which is 1, times 2. So what we're going to do is we're going to set up a little ratio chart here, just like what we've done in the past. So we have our hydrogen atom, we have 2 of them. So I'm going to take 2 times our hydrogen. This is where it's going to tell you how much each atom weighs. So our hydrogen weighs 1 gram. So to figure out the weight of a hydrogen, how much hydrogen is in 1 molecule, I need to take it times 1. 2 times 1. And so we're going to find out that the hydrogen weighs 2 grams. Then we have to figure out the oxygen. There's only 1 oxygen. If you look back here in the molecular formula, there's only 1 oxygen, but it weighs 16 grams. So we have to take it times 16. And we're going to get 16 grams. So the total weight of an H2O is 18 grams. But they asked us, they want to know if there's 3,600 grams of water. So we put that under the total column. If there's 3,600 grams of water, how much would the oxygen have to weigh? So we don't know what that is, so we'll call that O. We don't know how much oxygen. They're not asking for the hydrogen, so we don't really care about this. So I'm just going to cross that out. Now, if you notice, what we made is a proportion like what we've done many times before. We have, I'm just going to call this OX, so it doesn't look like a 0. So we can set up a ratio with these numbers once you fill in your chart. It's 16 over 18 equals our oxygen over 3,600. And then we would just cross multiply, and we would get 3,600 times 16 equals 180x. Divide both sides by 180. And we would get that our oxygen, I lost my O, our oxygen, let me just cross that out, oops, should be 18OX. Looking like a 0. Let me just erase that. We're going to get our oxygen equals 3,200 grams, just for our oxygen. Be careful with your O's because they can look like zeros. Let's look, if you don't understand that one, we're going to try another one that's very similar. So let's look up here at example 2. This time our molecule that we have is ammonia. And they write ammonia NH3, where our hydrogen is going to weigh 1, like it did in the last one, and our nitrogen is 14. So we're going to do the same thing. We have 1 nitrogen. See how there's not a subscript down here? That would be 1. So we have 1 nitrogen, so we take our 1 nitrogen times how much our nitrogen weighs. Our nitrogen weighs 14. So we have a total weight of 14 grams for the nitrogen. Let's get a hydrogen. Hydrogen, if you look at this little 3, it says that we have 3 hydrogen atoms. So we have to take 3 times the weight of the hydrogen, and hydrogen weighs 1. So it's just 3 times 1 equals 3. Once again, we write our total column here. Our total would be 17. And they're asking if we have 510 grams of ammonia, how much nitrogen do we have? So this time we don't know what nitrogen is, so we're going to put an N there for nitrogen. Again, they're not asking for hydrogen, so we can just cross that one out. Now we have a simple proportion like what we've done many times in the past. So we write 14 over 17 equals N over 50. And once again, you're just going to cross multiply, and you're going to get 17N equals 514 times 510. Divide both sides by 17, and we're going to get the nitrogen equals, I ran out of room, so I'm going to shrink this. Nitrogen equals 420 grams. So the main thing to learn in these problems is you have to take whatever the subscript is times the weight of that atom and put it in a proportion. So let's do one more before we move on to parallelograms. This is NH4Cl, which is ammonia chloride. They're giving us this. They're giving us the weights of each different part of it, and they want us to find out how much chloride, how much does the chloride, which is the Cl, weigh if the whole molecule weighs 1,060 grams. So this time we have 3 atoms that we have to write. So we have our nitrogen, our hydrogen, and our chloride. And then we're going to have our total column again. So let's start. We have 1 nitrogen. We know nitrogen weighs 14, so it's 1 times 14, so that's just 14. We have 4 hydrogen this time, and hydrogen just weighs 1. So it's 4 times 1, which is 4. And chloride, we just have 1 again. 1 times chloride weighs 35 grams. 35. And so that's 35. And then we have to add them all up, and it comes to our total is 53. They want to know how much does the chloride weigh. So we don't care about nitrogen or hydrogen, we just want to know how much chloride. And they tell us the total of the molecule would weigh 1,060 grams. So there we go, we have our ratio again. Look, we can just put our lines here if you want, make it easier. Cross multiply and solve for Cl. So we get 14,400 equals, whoops, wrong problem. Copying the wrong one down. It would be 53 chloride equals 35 times 1,060. And if you divide by 53 here and multiply that all out, the chloride atom weighs 700 grams. And that's it. Just check this, re-watch this, watch it slower when you're doing your problems, and you shouldn't have any problems with these.